Assalamualaikum warahmatullahi wabarakatuh. So for today, my name is Nurul Ain Nadhirah Binti Mohamad Nasri with the matrix number P23161330. So for today, I will present for my subject MTES3232 Curriculum Studies and Learning Theories in Primary School Mathematics with the title of Application of PJET's Cognitive Learning Theories and Constructivism in Teaching Mathematics. Okay, before we dive into the constructivism theories and pigeon theories, let us look into what is curriculum. So, curriculum is the structured plan of learning experience and outcome designed for student. But curriculum help teachers to teaching the student. So, curriculum studies focus on the design, development, implementation, and evaluation of educational program. This curriculum involves three things: selecting contents on what to teach, designing pedagogy strategies on how to teach, and aligning with educational goals and students' needs. So, to have clear sight of this presentation, we must know what is the objective of the presentation. First of all, the objective is to explore on how pigeon theory and constructivism apply to math education. So, for two, discuss the role of curriculum in fostering critical and creative thinking. And the third objective is to provide strategies for integrating critical thinking, creativity, and ethical reasoning. For the fourth reason is to address individual difference in learning. Next, we must know what is the importance of curriculum in education. First, it provides a structured framework for teaching and learning. Second, it helps students develop knowledge, skill, and value needed for life. And the third one is to ensure consistency and quality in education. And the fourth one is to adapt for societal change and individual learner needs. So, curriculum have many importance in. So, based on the four important things that I have said earlier, we know it shows that curriculum is essential in our education. So, without wasting any time, let us dive into the pigeon and constructivism theories. So, this curriculum is a structured plan that have improved from years to years, and it started in the year of 1949, where Stylus model is designed. Stylus model is a linear approach focusing on objective, content, instruction, and evaluation for students and teachers. Second model of curriculum is Tabas model in 1962, where it emphasized teacher involvement in curriculum planning and inductive development. And the third one is Bruner's spiral curriculum in 1916, where the concepts are revised and expanded upon over time to deeper understanding. And the last one is for Stenhouse process model in 1975, where the curriculum is viewed and flexible guide, allowing the teachers to adapt in based on student needs. The four key components in curriculum design is the assessment and evaluation, where teachers measure students' progress and curriculum effectiveness. And the second one is to teaching strategies and learning experience. It focuses on instructional method that facilitate learning. The fourth one is for the content selection and organization of the teaching, where the curriculum determine what knowledge, skill, and value should be taught. And the fourth one is the aim, goal, and objective of the learning itself. So, curriculum help to establish the purpose of education and expected learning outcome. So, we have basic knowledge of curriculum now. Let us dive more about the learning theories. The first learning theories that I will explain is about the pigeon cognitive learning theories. Based on its name, it is proposed by Jean Piaget in 1896 to 1918. And this pigeon cognitive learning theories is a curriculum that theories that actively learning occur through active method, process, and its structure in stage. So, it focuses on how the children construct knowledge through active exploration. So, cognitive development occur in stage based on age. Basically, the pigeon cognitive learning stories state that knowledge of every age, every stage is different. So, let us look more into this topic. So, the stage of cognitive development in pigeon theories, we have four. The first one is sensory motor stage for 0 to 2 years, And the pre-operational stage is 2 to 7 years, and concrete operational stage is 7 to 11 years, and the last one is the formal operation stage, where it's 12 and above. So let's explain the first one, where the sensory stage start. It starts from the baby and until the 2 years. So this sensory stage is about learning through sense and motor action, where the kids development of object permanence. It have object permanence in itself. So the second one is pre-operational stage, where the egocentric thinking, where it's difficult to see others person perspective. In this stage, the child only see the perspective from his or her mind. So it's developed of symbolic thinking but limited logical reasoning. She or he have logical reasoning but very limited at this stage. So the third stage is logical thinking about concrete object. Here, the kids start to thinking using logical thinking about the concrete object, where he or she can look into the object. So it's understanding of conservation and reversibility. It combines the logical thinking and understanding to make it conservation and reversibility. So in this stage, the kids also have the ability to classify and organize objects. It's suitable for you to improve the organization and classify by ask them to organize the things using their own scope. So the last one is the formal operation stage, where the abstract and hypothetical thinking is involved. Here, the logical mind is more developed, and it also have hypothetical thinking, and problem solving and logical reasoning more improved. So here, the kid using more about the problem solving and logical reasoning. Okay, so the first activity that the teachers can conduct for the sensory motor stage, the youngest stage, is peekaboo shape, where the student exploring object permanence and basic geometry. So the step is to show the baby a shape of a circle, a hexagonal, triangle, and let them touch and explore it, because then it's cover the shape with the clothes and place it in the box to encourage the child to look for it, pulling the clothes away and reaching into the box. For here, the child will touch the shape without looking it, so it improves her sensory motor skill. Then the child need to name the shape when they find it, or we can help as a teachers or ask a conductor. When the child found a shape, we can say about the name shape, so the child can recognize the name of the shape and relate it. So this step will be repeated in different shape and letting the child engage with the activities. So here, the activity help the infants develop object permanence while introducing basic shapes. So here, the objective of this activity is to help the infant to develop the object permanence while introducing basic skills. So here, the child know the name of the shape and how it's look. Here I will explain more why this activity need to be done to the sensory motor stage. So the first one is support object permanence and a key development in the sensory motor stage. So in this stage, we need more activities that involve her hands-on and sensory motor skills. So here, we apply the hands-on activity and the sensory motor, where the child itself can touch and feel the shape. Other than that, this activity is needed for certain hand and eye coordination and fine motor skill. As example, when he pick up a shape from the box, he know what it feel, and he know how it's shaped. He can look at it and know how it's shaped. As example, if he pick up a circle, he know that circle is in the shape of the planet, in the shape of without the vertex. So next, in this activity, why it works? Because it helps infant recognize and differentiate between basic geometry shape. Here, he can recognize every shape, like what the difference between circle and hexagonal, what the difference between triangle and square. For the application of learning of PJAT learning theories in mathematics activities, the first one is stage-appropriate mathematical tasks, where it design activity that align with student cognitive development stage. As example, we use hands-on object for addition and subtraction in concrete operational stage, before introducing the abstract symbol. The second one is for discovery-based learning, where we encourage students to explore mathematical pattern rather than memorize the formula. And student can discover multiplication pattern through repeated addition using number blocks. So the third one is problem solving and logical reasoning. These activities should promote student reasoning abilities, as example giving puzzles that require logical deduction and such as Sudoku and number sequence. Next is the use of errors as learning opportunities. So here student maybe do some mistake but the teacher still can help it to correct it. So the student can learn the correct thing and implement only the correct thing and remove the errors or the mistake that he or she make. Next is the use of errors as learning opportunities. So here student maybe do some mistake but the teacher still can help it to correct it. So the student can learn the correct thing and implement only the correct thing and remove the errors or the mistake that he or she make. Next, for the concrete to abstract learning. So, use manipulative as cue, counter before translation to abstract symbol. So, the teaching fraction with fraction strip before using numerical representation. So, the student can look of the fraction and it's in their hands. So, they can know how many fraction in front of he or she. Next, for the focus on conceptual understanding over rote learning. So it promotes deep understanding rather than mathematical computational. The example as instead of drilling equation, student explain why a solution works. With the deeper knowledge, he or she can know and how to solve it. The key concept of these theories is the schema first, for the mental framework to understand and respond to experience, the assimilation for integration new information into existing schema, and the third, accommodation, modifying schema to fit new information. And the next one is equilibration, where it's balance between assimilation and accommodation for cognitive stability. So here, pigeon theories in educational implication can apply in learning should be active and discovery based, while constructivist learning approach is applying. So, teaching strategies should align with a child development stage, and hands-on activities help concrete learners. And the learning occurs best when students explore and discover concepts on their own. As earlier, I said that the student can learn from their mistake. That is where the student explore and discover concepts on their own, or when they search for their own knowledge. The third activity is for pre-operational stage, where we call this is matching and sorting games. The objective of these activities is to help the children to understand the properties of object and build classification skill. So, why is this? The activity instruction is first, give children a variety of shape as circle, square, triangle, and ask them to group similar ones together. And ask them to sort by color, put all the red button in one pile and the blue one in another. So, this encourages sorting by size, as big with big and small with small, and using block and everyday item like spoon and cup. We can apply this by ask the student to search for the things in the classroom and classify it with shape or the color or the size. So, why is this game important? Because it develops logical thinking. Children learn to categorize object based on common attributes, and it's build early geometrical skill by recognizing and sorting shape help in understanding 2D and 3D object. This also enhances pattern recognition, where the student identifies sequence help in future learning of number pattern, algebra, and coding. Next, for the application of learning of PJAT learning theories in mathematics activities, the first one is stage-appropriate mathematical tasks, where it design activity that align with student cognitive development stage. As example, we use hands-on object for addition and subtraction in concrete operational stage, before introducing the abstract symbol. The Second one is for discovery-based learning, where we encourage students to explore mathematical pattern rather than memorize the formula. And students can discover multiplication pattern through repeated addition using number blocks. So the third one is problem solving and logical reasoning. These activities should promote student reasoning abilities. As example, giving puzzles that require logical deduction and such as Sudoku and number sequence. We can add after the sorting to ask the student why they group object in a certain way to encourage reasoning skill. So next we can introduce real-world sorting by organizing household objects such as socks by color, fruit by types, or anything else. Next, the implication of cognitive learning theories and conceptuality in teaching mathematics. The first one is differentiate based on development stage. Teachers must adapt teaching strategies to student cognitive abilities, where the teachers maybe can teach with fraction using PISA model in primary school before moving to fraction algebra in secondary school. Here, we strengthen the base knowledge of the student by presenting the concrete model of the fraction itself. Next, for the conceptual understanding of overall learning, the teaching should focus on meaning and understanding rather than memorization. As example, encourage students to derive area formula, then memorize them. Here, we help the student to have the deeper knowledge of the formula itself. Next, we can use of hands-on activities. Like teaching should involve manipulative tool for younger learners. As example, we can use Crucianine routes to explore number relationship. Next, implication of cognitive learning theories and conceptuality in teaching mathematics based on use of hands-on activities. These activities can physically manipulate objects to understand mathematical concepts, and sorting and touching differentiate makes learning tangible. Next, these activities help to encourage verbalization and active participation, where name the shape and describe their reasoning, or strengthen their understanding and language skill reinforce early mathematical vocabulary. So next is symbolic thinking, where it still needs real-world connection by linking shape to real-life objects. As clock, as a shape in circle, they bridge the gap between concrete and abstract thinking. So next is address egocentrism. Children are exposed to different ways of thinking when working in a small group and learn to consider other people's perspective, where it helps them gradually to move beyond the egocentric thought. So, why hands-on activities are essential for early mathematical skill? The first one, because the shape recognition activities help the fundamental concept in early geometry for children to identify and describe the 2D shape. Next, hands-on activities involve in sorting and classification, where it helps in children development logical reasoning and essential for problem solving and algebraic thinking in later year. Next, hands-on help in pattern recognition. This is for the extension activity, where the student recognizing sequentially the fundamental for number pattern and multiplication and coding concept. The last one is for improved fine motor skill, where the student, when handling small objects like cutout shape, improve hand-eye coordination and improve important skill for writing number and drawing geometric figures later. Okay, next, the last activity that the teachers can do for the formal operation stage for students in 12 and above years, we can do the activity of measurement treasure hunt, where we understanding measurement in real life. The instruction begin with give students a list of items around the classroom or house to measure. Next, we ask them to estimate the length before measuring it using the measuring tools. So we give them use ruler or measuring tapes to find the actual length and compare with their estimation. And for an extra challenge, we can ask students to convert between unit as cm to mm or cm to meter. Next, we end these activities with the question such as with the discussion, and we can start the discussion with asking a question like which object was the longest or which object was the shortest. This measurement treasure hunt help by develop logical thinking and comparing estimation and real life measurement. So next, it reinforces conservation. Length remain the same even if an object is moved. Next, we strengthen the classification skill by sorting object by size. And the last one, by encourage real-world application of math concept in real life in their classroom. So we provide the knowledge that math is always all around us. For the implication of cognitive learning theories and constructivism based on individual difference. First, this pigeon learning theories teach about the stage-based learning adaptation and active exploration for different learning styles. So for the last activities is building a dream city geometry in real life for the formal operation stage 12 and above years. Here, we applied multi-sensory learning for different learners. So, the objective is to help the student apply geometry and algebra in real-world scenario, developing abstract reasoning, problem-solving, and critical thinking skill. So here, we have 4 approaches: visual learner, auditory learner, and kinesthetic learner, and logical learner. So here, we can give differential instruction that's suitable for the way of learner of the kid. So as example, the visual learner can create 3D blueprint and digital model using geometry software. As example, the geometry software that they can use as SketchUp, GeoGebra, Desmos, or any game online. Or the famous one is the Minecraft. So for the auditory learner, they can present their design in an oral presentation. So to explain the mathematical reasoning in the model. So for the kinesthetic learner, we can build a physical model using cardboard to explore spatial relationship. And logical learner can help by solve advanced optimization problem on how can we minimize construction costs while maximizing the space. So the requirement for these activities is to calculate the shortest distance between the building using Pythagoras theorem and use angle and geometry to design road and skyscrapers, and develop a scale model with accurate proportions. So here the picture of the application of these activities. The first one on the right is the city using Minecraft, where the student can do it themselves, and the physical model where the student using the cardboard or any physical object to make it a dream city of themselves. So next is the constructivism learning theories. The theories is about learning is an active process where the student construct knowledge based on experience, and learners build their own understanding based on experience. Knowledge is not passively received but actively constructed in this theory. So in this constructivism learning theories, we have 6 key principles. The first one is active learning, second scaffolding, third ZPD or zone of proximal development, fourth is social interaction and collaboration, 5 multiple representation, and 6 is constructivist teaching method. Here is the important thing in this learning theory. 2 types of constructivism. The first one is cognitive constructivism and the second one is social constructivism by Lev Vygotsky. Cognitive constructivism focuses on individual cognitive development, while social constructivism focuses on learning occur through interaction with others. The activities that apply these constructivism theories is in the game, an online game where the name of the online game is Fruit Spec, where this game aligns with constructivism learning theory by making number comparison engaging, interactive, and learner drive, and it allows students to construct their own understanding through experience rather than rote memorization. As I said earlier, the constructivism theories have 6 key principles that we will derive more. The first one is for active learning approach, where the player will engage in hands-on activity where they are actively compare number and apply their understanding rather than passively memorize the concept. And the second one is scaffolding or ZPD, where the game provides a structured but exploratory environment where players gradually build their understanding by encountering different number comparison of varying difficult level. And the third one is the student-centered learning, where the student actively engage with the game by making decisions on numerical comparison instead of simply memorizing the rules. And this game provides instant feedback by allowing students to adjust their strategies and learning from their mistakes. And since this game adapts to the player choice, each student experience and a personalized learning journey on their own pace. The fourth one of the key principle of this theory is social interaction and collaborative learning. So the teachers can encourage peer interaction by having students compare their strategy or explain their reasoning to classmates. This gamification naturally fosters competition and teamwork, motivation students to engage with each other while reinforce their learning. So the third one, the key principle of this theory is multiple representation of mathematical concept, where it shows the clear visual where floating number make learning easy to see and understanding. And here, symbol matching players connect and with the real number, less than or more than with the real number. So this can also help in hands-on learning where the student drag and selecting object makes math more active, more engaging. And it gives also instant feedback where the player learn from mistake right away and fun and engaging. This game is a game-based approach make maths enjoyable for the student. The last principle is problem-based and inquiry-based learning, where instead of direct instruction, learners discover the meaning of comparison symbol through interaction and experimentation and feedback. As I said earlier, the constructivism theories have 6 key principles that we will derive more. The first one is for active learning approach, where the player will engage in hands-on activity where they are actively compare number and apply their understanding rather than passively memorize the concept. And the second one is scaffolding or ZPD, where the game provides a structured by exploratory environment where players gradually build their understanding by encountering different number comparison of varying difficult level. And the third one is the student-centered learning, where the student actively engage with the game by making decisions on numerical comparison instead of simply memorizing the rules. And this game provides instant feedback by allowing students to adjust their strategies and learning from their mistakes. And since this game adapts to the player choice, each student experience a personalized learning journey on their own pace. The fourth one of the key principle of this theory is social interaction and collaborative learning. So the teachers can encourage peer interaction by having students compare their strategy or explain their reasoning to classmates. This gamification naturally fosters competition and teamwork, motivation students to engage with each other while reinforce their learning. So the third one, the key principle of this theory is multiple representation of mathematical concept, where it shows the clear visual where floating number make learning easy to see and understanding. And here, symbol matching players connect and with the real number, less than or more than with the real number. So this can also help in hands-on learning where the student drag and selecting object makes math more active, more engaging. And it gives also instant feedback where the player learn from mistake right away and fun and engaging. This game is a game-based approach make maths enjoyable for the student. The last principle is problem-based and inquiry-based learning, where instead of direct instruction, learners discover the meaning of comparison symbol through interaction and experimentation and feedback. For the applying constructivism in mathematical activity, we have ZPD, real-world problem solving, collaboration learning, and peer discussion, and multiple representation of mathematical concrete. So the first one is ZPD and scaffolding, where provide guidance support for difficult tasks, gradually reducing how a student gain confidence, where helping students set up an algebraic equation before letting them solve similar one independently. So for real-world problem solving, we connect the mathematics to real life application, where we're using static to analyze data from a school survey. Next, we collaborative learning and peer discussion, where we encourage the student to work together and explain their reasoning. As example, we can do group problem solving activities where the students justify their own answer. They can discuss their answer and hear other people's perspective. Here, next, we can multiple representation of mathematical, where we use inactive hands-on and iconic for visual and symbolic abstract method. As example, we can teach in geometry with 3D model before using the formula itself. Next, the implication of cognitive learning theories and constructivism in teaching mathematics. So the first one, we use the scaffolding, where the teachers should provide temporary support and then allow students to work independently. As example, we demonstrating a problem solving technique and then allowing students to apply it in different contexts. The second one is student-centered learning. We encourage students to actively construct knowledge rather than passively receive the information. Where with inquiry-based learning, where students explore mathematical concepts and draw conclusions. And the third one is integration of technology and visual tools, where constructivism teaching encourage digital tools for deeper exploration. As example, using GeoGebra to visualize graph and geometric transformation. The implication of connective learning theories and constructivism based on individual difference, we have ZPD and personalized learning, and use multiple representation to support learning style. ZPD and personalized learning said that each student require a different level of support based on their learning abilities. As example, students struggling with word problem receive guidance step-by-step scaffolding, while advanced students work independently. Here, the student can adjust their learning strategy based on their learning ways, personalized learning. So next, we use of multiple representation to support learning style, where we provide interactive, iconic, and symbolic teaching method to support the student with diverse cognitive abilities. As example, the teachers can use the 3D geometry with real-life model as diagram or equation to cater to different learner. So, we must apply the geometry knowledge of MTES3232 to help teachers address individual difference in class. The first one is use multiple teaching strategy, where different students learn based through different approach as visual, kinesthetic, and symbol. So some students understand angle better through protractor or hands-on, and while others grab their through on visual or graph or picture. Next, we can use scaffolding geometry concept based on student readiness. So the teacher can provide step-by-step guidance for students who struggle while challenging advanced learner with extension tasks. As example, some students work on basic triangle properties while others explore Pythagoras theorem proof. And next, on how geometry is applied by integration of technology to cater to different learning methods. As I said earlier, we use GeoGebra or SketchUp or Minecraft to apply this geometry in mathematical learning. Based on my research and reading, I have learned that application in curriculum can do in 3 ways. First, concrete to abstract approach. Second is problem-based learning, PBL. Or third is zone of proximal development, ZPD. The first one is using manipulative block or diagram to help students grasp the mathematical concept before transition to abstract representation as formula and the basic knowledge. And next, for the PBL, we encourage students to explore real-world mathematical problem and find solution. For the ZPD, we differentiate instruction based on the different student readiness and ability to progress with the support from the teachers. For the essential question, how does the content selection in primary mathematical curriculum foster our student ability to think critically and creatively? The first one is for encouraging logical reasoning and critical thinking. The second one is promoting creativity through exploration and multiple reasoning representation. The third one is inquiry-based learning and hands-on activity. The fourth one by applying the integration of high-order thinking or HOTS in the skills. Okay, the second question of this essential question is said that how can educators ensure the seamless integration of critical thinking, creativity, and ethical reasoning into the teaching progress? The first one is for encouraging logical reasoning and critical thinking. The second one is promoting creativity through exploration and multiple reasoning representation. The third one is inquiry-based learning and hands-on activity. The fourth one by applying the integration of high-order thinking or HOTS in the skills. That's all with the end of the essential question. Here we have come to the end of our presentation. Thank you very much for spending your time with me, and till we meet again in the future. Thank you.